revolution in the polders. The first one is strategic drainage during the rainy season so that we can cultivate HYV and get earlier harvest. Drainage shortly before almond harvest in early November so that the soil can dry down, so that we can have timely establishment of rabi crops and grow high-yielding, high-value crops. Thirdly, intake of water from the rivers while they're fresh. There's a perception that all of the coastal zone is suffering from salinity. It isn't. There are areas where there's huge amounts of fresh water in the river almost year-round that are currently untapped. This CPWF phase 1 that showed that desilting of the culls can increase the storage capacity for irrigation significantly, and of course it will also facilitate drainage. The same project also showed that borrow rice can be established earlier in the coastal zone because it's not as cold down there as it is in the traditional borrow areas. So this reduces the amount of water that you need to store to finish off the borrow rice crop. And in areas where water is really scarce, then we can grow high-yielding, high-value rabi crops because they only need 2 or 3 irrigations to get very good yields. Plus they're using the residual soil moisture. A few other attributes we need tolerance to water stagnation for almond throughout the coastal zone. We need submergence tolerance for both almond and ash. This is an example in a gare, which is an impoundment used to grow both brackish water shrimp followed by rainy season rice. And the second transplanting, this is the second transplanting here. It was inundated for a week, but Biridan 52 did quite well. So we have some good germplasm. So we also need salinity tolerance for almond in high salinity areas, and this is particularly in the gares for the rice following the brackish water shrimp. Water management in the gares also has a big influence on salinity for almond rice, and this is from 2 farmers' gares. In this case, the farmer was very concerned to have a good almond rice crop, and so he had good drainage and allowed good leaching by rainfall before he established the rice. And so the salinity always stayed below 4 decisiemens per metre. In the other gare, after transplanting, it fluctuated from 5 to 7 decisiemens per metre. But the good news is that some of the varieties did very well in both salinities. And Biridan 44 was the star this time, but there's several that were doing pretty well under those conditions. So we've come up with a number of what we think are the cropping systems for the future. And the first couple I'll describe are for the low salinity areas. And this one involves triple cropping with rice. We can get about 16 tonnes per hectare of rice a year instead of the current 3. And we do this using short duration salt tolerant, well, we use HYVs for all crops, short duration salt tolerant for the almond, medium duration water stagnation tolerant and ideally submergence tolerant for the almond, and medium duration borrow sown early. And we've successfully done this for 2 years now in polymer 43. For the breeders, we'd like a few more things though. We'd like to have submergence tolerance and high temperature tolerance during flowering in the oush. And of course, we'd like all of the tolerances combined into single varieties. And we'd like much greater cold tolerance in the borrow so we can be a bit more flexible about growing date. It's very sensitive at the moment. This is almost the same system. The only thing that's changed is instead of a borrow rice crop, we've got a rabi crop. In the picture it's sunflowers, but it could be maize, watermelon, chilies, all sorts of things. And we've already achieved 10 tonnes per hectare of rice, 8 of maize, and 3 of sunflower in these systems, again for 2 years in Hold 43. In the more saline areas, where the water's a bit short, we can only manage 2 crops a year. But again, high-yielding varieties in both seasons with similar tolerances. And we've also successfully implemented that. But we'd also like shorter duration and salinity tolerance in the borrow rice. If we have shorter duration, then that reduces the amount of water we have to store in the bulb. tolerant, well, then we can cope even better with the developing salinity. And this is one of the systems we're looking at in the high salinity areas, and this is for the shrimp rice system. Shrimp is a very high value crop, but it's extremely risky. The total crop can be destroyed by virus, and it's really badly managed at the moment. So with our World Fish partners, we're implementing a lot of improved management, good drainage and leaching at the end of the shrimp. But the really important thing also is the addition of fish into that system. So even if the shrimp die, the fish is still profitable. It's really hard to control disease at present because again, it's a community thing. If you use disease-free seed and you filter all the water coming into your gare, you can still get contaminated from neighbouring gares or from birds. During the rice phase, we're growing fish and prawns with the rice. At this stage, we haven't properly demonstrated successful rice production in these gares, and again it was because of a water management problem. In the whole region, we needed to drain, but everybody needed to drain, but the drainage system isn't good enough at the moment, and so the water in the gares was too deep, and so on. But that's the system for the future. So we believe we've got lots of improved cropping system technologies for greatly increasing productivity, but that's only half of the challenge. The other bit is how to implement it, and it needs a real change in mindset. Engineers who determine how most of the huge amount of money in the polders is spent pretty much see polders as islands with embankments and sluice gates around them, and they're not aware that things have changed since the time when we wanted to just grow one traditional almond crop in the rainy season. We've now got the technologies where we can fit 3 crops together and greatly increase yield, so we need to do other engineering works inside the polders. And we need a lot of investment in integrated polder so that we can achieve that integrated polder water management. And we also need investment in agriculture and aquaculture to help farmers pick up the new technologies. And we also need cropping system zones because you can only manage water in units. So Andy is now going to tell us where they're up to in terms of can we adopt any of these improved cropping systems anywhere now, and what about the future?
Thank you, Liz.